Okay, now for this week, I want to go over a little bit of how the binomial probabilities work in Excel. And actually, in Excel, they work better than the examples given on the calculator because we can list things out and work them together. So the example problem I have here, a survey of college students shows that 32% dropped a class last semester. So if a random sample of 14 students is taken, find the probability that. So what we have here so far, remember, n is the number of trials. In this case, the number in the sample. So for this problem, n is going to equal 14. P is the probability of success on an individual trial. For this case, since it's 32% of college students dropped a class last semester, that means the probability is 0.32. 32 out of 100 is what 32% literally means. You divide that out, you get a probability of 0.32 is the probability that an individual student had to drop a class last semester. So let's say we want to find the probability that exactly 6 students dropped a class. We're going to imply last semester. So out of those 14, the probability is exactly 6. So n is 14, p is 32, x now equals 6 because we want to exactly 6 dropped a class. The formula in Excel is equals binom dist. Now you can see the prompt that comes up, number underscore s means the number of successes. So that's x. So 6 is the number of successes. Next it says trials, that's n. So that's going to be 14 trials. Next is probability of success, underscore s, that's the probability of success. That's our 0.32. The final thing is cumulative. Cumulative is asking, are we really using the binom CDF or the binom PDF? If we say false, we're telling Excel that we only want the probability of exactly 6. We don't want 6 or less. That would be the cumulative probability. You want to stick with just the probability distribution. So we get 0.14741 is that probability. Now what I'm going to do here is I'm actually going to set up the probability distribution for this one. So we're going to look at the number of students and the probability. So this is the number of students out of 14. Now we got to include 0 in here because there's a chance that none of those 14 dropped a class. Now we're going to number from 0 up to 14. Oops, get back there. So there's 14, so that the distribution goes from 0 to 14. So we're going to equals binom dist. Now for probability of success, I'm going to click on the 0. What that'll do is every time I pull this down, it'll go from 0 to 1 to 2 to 3 successes. Trials is going to be 14, and probability of success is 0.32. And I'm going to stick with false. If I pull this down, I create my probability distribution. Now you see those E's, that's scientific notation. If I extend this out, I should be able to get rid of that, and it doesn't. So let's do this. We're going to go to Format Cells. And in my number, we're going to go to number instead of general. And we're going to go to 10 decimal places. That should get rid of them. There we go. That was scientific notation. What that meant was the E, here, let's go back here. That E -7, that meant that you have to take that decimal point and move it 7 spots to the left. So that would be a decimal point with 6 zeros and then the 118. So I'm just going to reformat them so we don't have them in that scientific notation. So these are our probabilities. If I add them up, they should add up to exactly 1, which they will. Remember, a probability distribution has to add up to 1. Let's look at the cumulative probability. So equals binom dist. Number of successes, I'm still just going to click here. So that's 0, 1, 2, 3, whatever. Trials is 14. 0.32 is my probability of success. I'm going to type in true for cumulative, which means that it's going to be from less than or equal to that number. Now notice for 0, the probability stays the same because there's nothing else less than 0, so there's nothing else that would be added to it. But as we pull this down, you'll see this probability is the 0 plus the 1 added together. This is 0, 1, 2, and 2 added together. This is 0, 1, 2, and 3 added together. And you'll notice the probability of 14, well, that has to be 1 because less than or equal to 14 includes every possibility. So that has to add up to 1. So anyway, let's say we want to know no more than 5 drop to class. So that is saying, from 0 up through 5. It does include 5. No more than 5 includes 5. So that would be adding these probabilities right here. So I'm going to do that first. Equals sum, and I'm just going to add those 0 through 5. You'll notice that is the same as what the cumulative probability would have been for 5. So I could have just done equals binomial dist 5, 14, 0.32, then put in true to make it cumulative. So that what that's saying is this first number here of 5 successes, true is saying we want 5 or less. So 0, 1, 2, 3, 4, or 5. And we get that same probability there. Okay, so next step. Oops, get back here. Less than 5 drop to class. Now less than 5 does not include the 5. So that's 0 to 4. So there we would have to add up the 0 to 4, which we could do over here. Or we could look, that'd be the same as the cumulative probability for 4. So the function we would type in would be equals binomial dist. Only 4 successes. Even though it says less than 5, that does not include 5. So we can only go up to 4. 14.32. And this would again be true because we want 0, 1, 2, 3, 4. So all the way up to 4. How about we say ask at least 8 drop to class. So this is 8 or more. So that would be from 8 up to 14. So let's do that sum first. That sum of 8 up to 14. Now what you're saying is this includes 8 to 14. The way we would calculate this is we would say, let's include the whole thing and take out 0 through 7. So that's 1 minus 0 to 7. 1 is the probability of everything right here, and we're just going to take out the 0 through 7 here. So the way we'd punch that in is we'd equals 1 minus binomial dist. We're only going up, we're taking out up to 7. What we're putting here, when we do 1 minus, what goes in the binomial dist is what we're getting rid of, what we're excluding, not what we're trying to find. So it's 1 minus binomial dist 7, 14.32, and true again because we're excluding from 0 up through 7. And you see we get that same probability. We say more than 8 drop to class. Well, again, now we want not 8, but it's 9 to 14 because the 8 is not included. So that is 1 minus 0 to 8 we're getting rid of. So again, I could do a sum over here of 9 to 14, or I can do equals 1 minus. I'm taking the whole thing and I'm taking out the ones that aren't included, which is 0 through 8. So that's binomial dist 8, 14, 0.32, and true because we want the cumulative. We're taking them all out. So that is how we do that. What if we want to know what's the probability that between 6 and 10, we're going to put inclusively dropped a class. Inclusively means the 6 and the 10 are included. So here we're going from 6 to 10. So that would be equals sum 6 to 10. We would add up those 5 probabilities. So we get that. To do that with our functions, this is going to be the probability from 0 to 10, which is going to be that binomial dist with a true in there for cumulative, subtracting out the probability from 0 to, now we're including the 6, we're only going to subtract out from 0 up to 5. So we've got 0 to 10, and we're subtracting out 0 to 5. So equals binomial dist. 10 is going to be our first one. 14 trials, 0.32, and true. That's giving us the probability from 0 all the way up through 10. Now we have to subtract out binomial dist. We want to include the 6, so we're subtracting out up to 5. 14.32, and true. And there we go. We see we get that same probability. Now, if you're looking at these functions here and you're not saying, well, how do you get the 10 and the 14 and stuff in this function? Same here. Why is that a 5 there and not a 6 if we're going 6 to 10? You can always fall back. Oops. Didn't want to do that. You can always fall back on what I did right here. Make this whole probability distribution and then just add together the probabilities you need for that problem. The toughest part is deciding, more than 8. Does that include 8? Well, more than 8 does not include 8. At least 8 does include 8. Same here, less than 5, that's only 0 to 4. No more than 5, that's going from 0 up to 5. That's basically it on the binomial distribution for calculating the probabilities in Excel. It is pretty simple, as you see. The biggest thing is, deciding what your range is and whether you're adding in or subtracting out. Just like on the calculator, if you're doing from 0 up to a number, it is just that cumulative, and you use the true to make it cumulative. If it's greater than a number, then you've got to do 1 minus, just like you did on the calculator, like you would do on a calculator. And like I said, don't be afraid to fall back on just constructing the table and adding together the relevant probabilities. Now, the mean of a binomial distribution is simply n times p. So for this one, that would be 14 times 0.32. So 4.48, we would expect, on average, if we took several groups of 14 students and asked them how many had dropped a class, which ones had dropped a class last semester, we would expect on average 4.48 out of that group of 14 would have dropped a class last semester. The variance, that is n times p times 1 minus p. Now, some textbooks define q to be 1 minus p, but we're not going to worry about that. So that equals 14 times 0.32 times 1 minus 0.32, which will give us 3.046. Standard deviation is just equal to the square root of the variance. So that's n times p times 1 minus p. So that's going to be equal to square root of, I'm just going to be lazy and take the square root of the variance right above it. So 1.745. That's basically it for the binomial distribution. So I'm going to leave it at that. If you have any questions, please let me know. Otherwise, that should be able to get you through this week. I'll be doing another similar supplemental video like this next week for the normal distribution. Remember, our unit test, first unit test, is coming up. That's actually going to be next week as well. Next week is week 6 already. So that is unit test next week. If you need anything, please let me know. Otherwise, you guys have a great week.